Hi, my name is Sachi.
And my name is Marietta.
So today we'll be solving a problem about probability. So, what is the probability of randomly choosing a point inside the cylinder but not inside the cone that has the same base and
So, as
height
Sachi
as the
read, the
cylinder?
problem is about probability. So I'm going to go ahead and draw a figure for us. So that's somewhat what the problem looks like. And so, in order to answer the question, we have to know what it's asking us. So, in this case, we know that probability is the part over the whole, and the problem is asking us to find the probability of choosing a point inside of this shaded region. So it's any point that is in the cylinder but is not in the cone. And so this shaded region in this case, because that's what it's trying to find the probability of, would be considered the part. So I'm going to go ahead and call this the shaded region. And since we're finding the shaded region of the entire cylinder, we know that in this case, the whole is the entire cylinder. So now that we have this figured out, we can go ahead and start putting together an expression using this setup. And it's going to look like this. So the expression now reads that the volume of the cylinder minus the volume of the cone over the volume of the cylinder. So the reason I did this is because the cylinder is a 3D object, right? It's not 2D because cylinders are 3D objects and are not just flat figures. So we can't find the area, we have to find the volume in this case, because it's not asking about surface area, but it's asking about how much space. If you were to pick a point in all of this shaded in space, what is the probability of picking a point from here? So the reason why we have the cylinder minus the cone over the cylinder is this. We've already established that the whole is the cylinder because we're trying to find part of the cylinder over the entire cylinder. So that is why we put the volume expression of a cylinder as the whole part of the setup. And the reason we have cylinder minus cone is that we're trying to find how much area, how much space, what is the probability of choosing a point in this space that is not in the cone. So to find this leftover space, we can subtract what we don't want included into the part, which is the cone in this case, from the whole, which is the cylinder. And so that's why it's cylinder minus cone. It's because we're finding this area, this region, the shaded in region, not area, the shaded in region of the figure, and are not including the cone. So it's the whole region minus the cone will give us the shaded region. So in this expression, r stands for radius in both cases. H is the same variable throughout and stands for height. And that's because, as it tells us in the problem, this height right here is the same for both the cone and for the cylinder. So we can just keep that as the same variable right there. The B stands for base. And in this case, the base is this circle because it's the base of the cylinder.
First, we have to factor out an h from both the top of the fraction as well as the bottom. We are doing this to simplify the fraction so that we can find the final probability. So when we factor out h, we're left with h times pi r squared minus 1/3 of the base all over h times pi r squared. And so when we simplify the h's, they're canceled out because it's both on the top as well as the bottom. Since a fraction bar is also division, we're left with pi r squared minus 1/3 of the base all over pi r squared.
So where Sachi left us off is that we have this expression left over, right? We have 1/3, and it's all over pi r squared. So that's where we left off last. Now, because we know that the base is one of the circles from the cylinder, I can redraw it here for you guys. Right, there's a quick sketch for you. Since we know that this circle is the same base for the cylinder and for the cone, we can go ahead and plug in pi r squared. And that's because we're finding the area of the circle, which will be the base, because the base of a figure is the area of that base when it's a 3D object. So now the problem will look like this.
Now, since the top and the bottom both have pi r squared in common, we can factor that out as well. So a term must be common in all three parts since the top is joined with addition. So now we are left with pi r squared times 1 minus 1/3 all over pi r squared times 1. And so when you simplify the pi r squareds, we are left with, so since again the fraction bar is division, so now when we simplify the pi r squareds, we are left with 1 minus 1/3 all over 1, which also simplifies to just 1 minus 1/3.
Alright guys, so we've finally reached our end and we've been left with 1 minus 1/3. And so we can obviously use subtraction, and we get that our answer will be a probability of 2/3, which is also roughly 66.67%. And so this answer means that in this shaded region, if we were to pick a point from the entire cylinder, 66.67%, you have a 66.67% probability of choosing a point in this shaded region that is not in the cone. Alright guys, thanks so much for watching, and we hope you guys have a great summer. Bye!